Hi everyone. After the video, I tried to fix up the gearbox that I made in the previous video, and this is how it looks like right now. However, something that you guys might see missing right now is this pulley may not roll around very smoothly if we just end up using only the pulley by itself. What we need is a pair, or actually 3 or 4 bearings, that would end up making this pulley be really smooth when it is rotating with a cable inside, as it is being used as the lift pulley. So some things to remember. This is an M3 bolt, which means the diameter of the bolt is 3 mm long, and that means that the bearings that we would end up using should have a 3 mm inside diameter, or in short ID. And the outside diameter should not be too much bigger. It should be around the same size as this hole, which we can obviously change, but then this hole have to be at least a little bit farther away from the edges, so we are working in a very constricted amount of space right here right now. When it comes to bearings, I would say that there are 2 really good places to get them. One is MISUMI and the other is McMaster. So if we go to MISUMI, and then in both of these places, they allow you to download some CAD files that you would like to use. And to begin with, let's try to get bearings that might fit here. This time first at MISUMI, rotary motion, bearings, ball bearings. And we know that the inside diameter has to be 3, the outside diameter, let's go with 6, because the smaller the better. And usually we like economy bearings, so let's go with economy. Now that there's only one, let's try downloading this bearing to see if it is going to fit with the parts that we divided, with the parts that we made. Usually it's best to just download them as TEP files. Even though we're using SolidWorks, TEP usually works better, surprisingly. And now that it's downloaded, let's go ahead and open that so that we can import it. Downloads. That is a zip file, so we have to unzip it first. Let's drag that in here. Let's open the file, part server. This one. Yes, import diagnostics and no with feature recognition, but then we know that this is one of the bearings that we could potentially use. So let's save it as a SolidWorks part file. Bearing ID3, and let's try to insert it to check out if it may work. Let them be concentric. The pulley is a little larger, but then we can see that this will probably fit. And this means that the insides, this bearing may be a really good fit for us to use. So let's have 2 of these, and at the outer edges I hope to use a flange bearing so that it can keep its place, and then to make the rotation even better, use thrust bearings on the outside to make the rotation of this part very smooth. So what we are hoping is this would go somewhere in the middle of the in the middle of the two bearings, in the middle of the two pulleys, and then the thrust bearings would finish up by making up this amount of space. So let's use the evaluate features to see how far it is. That's around 1.85. That's 1.85 millimeters. On this side, that's 1.95. So if we get a bearing that's around 1.9 millimeters in thickness, it should probably work. So let's go back to MISUMI, and we also like economy. So let's go find an economy flanged bearing. And let's try downloading this to see. I guess this doesn't fit, so let's try to find some other file that there may be parts for. Oh, dust. This one. Let's download this. Let's wait a little bit. Download. For some reason this is not working. Let's try it on Windows Explorer. Yes, download, and it should be downloaded right now. So let's go ahead and unzip it. And we can open this one as well. So this is a flange bearing that we might possibly end up using. Let's see the distance. Let's hope that it's around so it's 1.65 mils, which means that it's good enough for us to use. Flange ID 3. So right now what we can do is we can add in that flange bearing like this. Let's pull that out and then define them. And we want the flange bearing to be on the other side as well, so let's make a copy and again divide. And now we have this part. Let's check how long this is so that we can redefine the size of the part that we're trying to print, the part that we're trying to 3D print. That's 8.8 mils thick. Currently this part is 8.80. Somehow it worked. And just in case it did not, we can always vary the size of the center part so that we know if it's going to work or not. So somehow it's going to fit like this. That part and that part would be in coincidence. Now we have this part that would be very freely rotating, but then to put this in the center where it would be very strongly bolted on both sides, we would need a thrust bearing. Sometimes not all desired parts are available at all websites. So for example, if you're trying to find bearings, if you're trying to find trying to find thrust bearings on MISUMI, you'll end up finding out that they don't sell thrust bearings that are of the sizes that we need. Their bearings start with inner diameter 10 millimeters. So this time let's go on to see what things they have for us at McMaster car. Let's search thrust bearings. We want ball and roller thrust bearings for sure. And although for thrust bearings they don't have one that's around 3 mils thick, we know that this is somewhere around 3 millimeters. So let's try downloading one of these. Once again, let's download the step file. Somehow Google Chrome's downloading is not working today. Let's go back to Internet Explorer and then save. We downloaded that. Here's the step file. Let's import it into SolidWorks. So yes, that's a thrust bearing. Let's save it as a thrust. And let's import it over here so that we can see thrust bearing. The point of this thrust bearing is to make this pulley turn smoothly, even if it is pushed against the walls of the gear pulley box. Let's copy that. And then let's try putting this in position to see if it fits. As you might see, there's some overlap and we may have to make some changes to this part. Let's check the distance, which is 1.8 mils. Now what we can do is make that wing part come up by 1.8 mils. So 19.8. And we can now see that it fits perfectly. We have to change the length of this part, but let's give that 19 point. And you can very easily and clearly see that the pulley assembly is finished. And it would have taken us a significantly longer period of time if we had to find out dimensions of each of these parts, measure them, and then use them to design the parts. And also, it would have been very difficult to be sure that the parts that we want to buy are the parts that we tested out. And this is something that has made my job as captain, having to buy new stuff, much easier, because I could exactly know if the purchase is going to work or not. That is the end for today, and I'll come back with a video related with how to print these parts so that they exactly fit the dimensions that you want them to. If you print these parts out right now like these, are you completely sure that they're going to fit the M3 bolts? Or could they be a little smaller? Could they be a little larger? And what did you do to check if their sizes are correct? So that's all for today, and thank you very much.